Now, we ask ourselves also about a couple of other things with functions. Is a function one-to-one? Is it onto? Is it discrete or continuous? So let's take these one at a time. First of all, one-to-one. If you have a graph of some function, you might ask yourself, is it one-to-one? Now, a one-to-one function is one where every y value has only one x value. See, for it to be a function itself, every x value has to have only one y value. And if you recall, one of the ways we decided whether something was a function was we used a vertical line. If a vertical line touches the graph in more than one spot or connects any two points of the graph anywhere along the graph, then it isn't a function. Well, in this particular case, it is a function. But now, if we want every y value to have exactly one x value, one of the ways we can do that is use what is called a horizontal line test. I'm having a little trouble with my horizontal line here. There we go. Now notice, when I bring the horizontal line up to here, it actually touches the graph in 3 spots. Now that means that it is not one-to-one, because let's imagine this is a height of 3. Maybe 1, 3 is on the graph, and let's make this 4 here. 4, 3 is on the graph, and 7, 3 is also on the graph. So we have one y value, 3, that has more than one x value. The y value of 3 has the x value of 1, it has the x value of 4, and it has the x value of 7. So to test whether a graph or a function is one-to-one, what we do is we use a horizontal line test. If a horizontal line can touch the graph in more than one point at a time, then it is not one-to-one. Onto, right? We'll get rid of that. Okay, now, if you have a graph, and let's say it starts up here, and it goes down like this and keeps on going, we would say that this graph is onto the real numbers, because every y, no matter where you go with y, will have an x. So if every y has an x, then the graph is onto, or the function is onto. So if an example of a function that is not onto the real numbers, for example, if you had what you've probably learned to call a parabola, notice there is no x where y is -3. See, the graph comes down below the axis a little bit and then goes back up, and they'll keep going in this particular direction. So there's no x number that you can give me that would have a y value of -3. Since there's no x for -3, we say that this graph is not onto. Discrete versus continuous. Well, now continuous is a pretty obvious concept. If you have a graph that's continuous, what that means is there is a smooth curve or a straight line that describes the graph. It's connected. It is continuous. Now, a graph that is not connected or continuous would be one that would, something like if you were talking about how many pizzas you could order from Domino's or something like that, you could order one pizza or two pizzas or three pizzas, but you wouldn't order the square root of two pizzas. In other words, the points of the graph would be disconnected, and something like this would be considered a discrete graph. So when you look at functions, if the points in between the points you're using to make the curve also have meaning, or in other words, if you can connect the graph and the connections have meaning, then we say it's continuous. If the points in between don't make any sense, then we would only plot the points, and that would be a discrete graph. And we're done.